Hello, boys and girls. Good to see you guys today. Today, we are going to continue talking about our big idea, which is bridges. Remember, fourth grade, that you guys are, with these videos, we're just simply looking at the details of the bridges, taking maybe a deeper look at how they're made. I'll give you another wonder for you to look into. But the main point is today, we're just going to look at some pictures and notice some of the details and patterns of the bridges. And today we're going to be talking about the third kind of bridge that I noticed on my trip to Waco. So let's get started. All right, so once again, this is part 3. If this is the first time that you watch this video, I want to encourage you to go back and make sure you watch part 1 and then part 2, where we talk about beam bridge and suspension bridge. But today we're going to be looking at truss bridges. Now, again, we had back in spring when we were still allowed to go out, we had a small trip to Waco, and I happened to notice the 3 different kinds of bridges right next to each other. So there's the famous suspension bridge. There's also a beam bridge right next to it. And then there's that famous truss bridge. I want to show a couple of pictures here. And I guess maybe because I am a math person, I love math, I love geometry. As a matter of fact, when I was in high school, that was my favorite subject, geometry, trigonometry. I really like using shapes. And so to me, truss bridge is just a beautiful design art. And I want you to, again, notice the details, notice look at the patterns on these bridges. So, of course, you probably already noticed the whole thing with triangles. So I think this is one of the reasons why this is my favorite kind of bridge, just because as you drive through it, man, I love to see all that geometry. Here's another picture. Now, I've seen a lot of common truss bridges used for trains because, of course, they can support a lot of weight. There's another truss bridge that has that arch look into it as well. And on this one, I do see a couple of squares and rectangles, also some sort of diamonds. But what do you notice? What else do you notice? I notice other bigger triangles as well, if you can see those right here. Look at that. See, this is what I'm talking about. Just love to see all of those. There's almost like an optical illusion as well when it comes to driving through these kinds of bridges. Now here's a pedestrian truss bridge. So these are only for maybe bikes and people to walk right over this little creek. But again, similar triangles. And then here's another one, again for a train to go underneath and then cars to go right above. Now, truss bridges are very expensive. If you can see the amounts of material, I mean, even in the one that we saw previously, this one here, I mean, that's a lot of steel. That's a lot of nuts and bolts that are required. So these are not very common when you compare it to a beam bridge. Beam bridge are the least expensive bridges, but in this case, these do require a lot more design and a lot more money. So that's why you don't see them as often, but they are pretty strong. So here in the red, you can notice the tension, and you can see on the green, the compression, the pushing. It is pushing and the pulling, the pushing and the pulling, the tension and the compression. If you remember from Bill 9, the Science Guy video that we watched. Here's some more in detail of how each of the parts of this bridge work. You have your floor beams as well. So a lot of engineering. I did find this pictures of some of the bridges that maybe one of these reflect the ones that you were starting to make. So you see some that are, had those triangles built right into it, or maybe on the top, and some that are just, maybe this is just a beam bridge here, but some of the ones here, you see the triangles as well. All right, so just to finish up today, I do have a Wonderopolis for you today. It's called Why Do Bridges Freeze Before Roads? And so someone asked, why do bridges freeze before roads? How does the ground beneath the road helps it to retain heat? Do bridges or roads conduct heat better? So this is a wonder that someone posted. And so I want you to, if you have a chance, go ahead and go through the article and just, get the meat out of it. There's a couple of videos here and some pictures, but as well as some information that could be helpful in case you have the same wonder. Listen, we miss you so much and we can't wait to see you back again at school. But in the meantime, this is the way that we'll continue to learn. So have some fun learning. Bye-bye.